Hello, this is Professor White. Today we will look at some basic trigonometric identities. So let's review what we already know. Now, we have a couple of them that we already studied in the previous videos. I know that tangent is sine over cosine. I know that cotangent is cosine over sine. I know that cosecant is 1 over sine. And secant is 1 over cosine. I know that cosine of negative x is cosine x, and it's an even function. I know that sine of negative x is negative sine x. That's an odd function. And when you put the even and odd together, you're going to end up with an odd function. And this also goes with secant. This also goes for cosecant. And this also goes for cotangent. These are the basic ones. Now, let's go and let's look at the next one. This is the Pythagorean identities. I think there's... All right. This is coming from, we did derive this in the unit circle, the equation of the circle. Sine square plus cosine square is 1. Now, we are going to start with that. What we're going to do, I'm going to divide 1 by sine square. So let's do that. You're going to get 1 plus cosine over sine, that's cotangent. 1 over sine squared, that's cosecant. Alright, so that is one of them. The other one is when we start with 1 again, sine square, cosine square. And this time I'm going to divide by cosine square. You're going to get tangent square plus 1. 1 over cosine square, that's secant square. You see, the formula 2 and 3 actually are driven from formula 1. Now, when they ask you to just do very simple identity proofs, things like if they say prove, let's say secant x minus cosecant x equals tangent x. These kind of tangent square x, these kind of proofs, just always break it down to sine and cosine. So let's look at that and start with one side and try to hit the other side. So I'm going to write, instead of secant, 1 over cosine. And instead of secant, again, 1 over cosine minus cosine. Alright? Then I go and I multiply top and bottom by cosine. Then I get 1 over cosine minus cosine times cosine, cosine square. and 1 minus cosine square. Remember, that's from the Pythagorean identity. One minus cosine square is sine square, which happens to be sine square over cosine square, which is tangent square. So simple proofs are actually very easy to do. Just break them down and use algebra to prove them. So let's do another proof from your book. We are going to prove this one. 1 over secant. They may ask us these questions as like simplify as well. 1 over secant theta minus tangent theta is secant theta plus tangent theta. Alright? Always break it down from one side and try to hit the other side. So I'm going to start with the left. And instead of secant, I'll write 1 over cosine. Instead of tangent, I'm going to write sine over cosine. Alright, and that will give me 1 over 1 minus sine theta over cosine theta, which is the same as cosine theta over 1 minus sine theta. It still doesn't look like what's on the right hand side. So maybe I'll have a different approach. I went from left to right. Now let's try to go from right to left. Go and manipulate the right and see if actually you can actually meet in the middle somewhere. So 1 over cosine plus sine over cosine, and this one is 1 plus sine over cosine. So if this proof is correct, what do I need to have? I need to have the right and the left match. Well, let me take the right and the left and see if they match. Cosine theta, 1 minus sine theta. Is that the same as 1 plus sine theta? I mean, you can do this proof a different way if you want. And this is actually a proportion. Just cross multiply. What do you get? Cosine square theta. And the right 1 minus 1 plus is 1 minus sine square theta. And what is 1 minus sine square theta? Cosine square theta. And that actually is a type of proof as well. So you could have done it a different way. This is another approach. You can start from right, from the left and then go to right, or right, go to the left, or kind of manipulate both sides and then meet somewhere in the middle.